Hello, and welcome back to the race, where we're going to compare these points racing around these conic sections. In order to do so, we're going to look at three assumptions: 1 lap per minute, theta increases at a uniform rate, and the units are in centimeters. In this session, we will determine the velocity of the angle, which, by the way, is going to come directly out of the assumptions above. First of all, we'll note that on any circle, the point P can have the following coordinates. The x-coordinate can be r cosine theta, as you see here. Similarly, the y-coordinate can be r sine theta, which, if we let r equal to 1, by the way, gives us this very well famous unit circle. So by using r cosine theta, r sine theta, the point P will begin on the positive x-axis and travel counterclockwise as theta increases from 0 to 360 degrees. Sometimes we call that the parametric equation. But note that there are an infinite number of places to start, and we can also go in either direction. So we really should call it the most common parametric equation, since there are an infinite number. But back to our situation. If we let C travel along the circle until we've swept out an angle of 39.5 degrees, using our agreed upon velocity of 6 degrees per second, that would be 6.58 seconds. And over here we have a stopwatch which is within 1/100th of a second of the same thing. The stopwatch also has a constant angular velocity of 6 degrees per second. So the red angle and the black angle would be equal. Note that we've defined our angular velocity to be 6 degrees per second, and that's true of any circle of any radius. So are all of the points on all of these circles moving at the same speed? What do you think? As they go around, are they moving at the same speed or not? After all, they each completed one revolution in the same amount of time. So far we have worked out that in the smaller circle and the bigger circle, we're 6 degrees per second. That's by definition. And we found out that the velocity of the angle moves around at a constant rate, which is also by definition. But don't worry, it'll get more tricky next time. Thanks for watching.